use the graph to determine the true frequency of the source. Let's take a look and see what is happening. So we have the relationship between apparent frequency and the speed of a moving sound source. The apparent frequency, the frequency measured by the listener, by the observer, versus the speed of the moving sound source. So 6.3, we're supposed to use the graph to determine the true frequency of the source. Let's just go through the question statement. You always want to do that. A group of learners conducted an experiment to determine how the speed of a sound source moving towards a stationary observer affects the apparent frequency of the sound heard by the observer. The results of the experiment are shown in the graph below. Right. So use the graph to determine the true frequency of the source. So when we are given apparent frequency, observed frequency, frequency detected by the listener versus speed, the true frequency of the source is the frequency we get when the speed is 0, right? Because when the speed is 0, it implies that there is no relative motion between the sound source and the listener. So there's no Doppler effect that is taking place. So here, when the speed is 0 meters per second, we need to read off the frequency. That is going to be the true frequency. That is going to be our Fs, frequency emitted by the sound source. So let's go ahead and do that. So this is 10, 20, 30, 40, 50. Yeah, so one block or one cell rather is 10 hertz. So from 150, this is going to be 160, 170, 180. So the true frequency 6.3 Fs is equals to 180 hertz. There we go. 6.4. Use the results of the experiment conducted at a source speed of 100 meters per second to calculate the speed of sound in air on the day that the experiment was conducted. So, right, let's take a look and see what is happening. We know that we have Fs because that is the true frequency of the source. The speed of... So what's moving here? Let's relationship between apparent frequency and the speed of a moving sound source. So we have Vs, it is the sound source that is moving. We have Vs, which is 100 hertz. So the listener should be stationary. We don't have situation where the listener and the sound source are moving in our context. One has to be stationary. Alright, plus is written here, stationary observer. Okay, so we are looking for the speed of sound in air. So it is V which we're interested in. Are we missing something? What else do we need? We need FL, right? We need FL, frequency, the apparent frequency, the frequency observed. So how can we get that? We can go to our graph and look for this speed, which is 100 meters per second, and find the frequency at which it corresponds with. So let me erase that because it's sort of blocking my view. My ruler. Where's my rule? So I'm interested at this point here. This point, right? And then I need to read off the value on the y-axis. So that is 250 hertz, right? So FL is 250 hertz. So the missing piece is determining whether the sound source, well, is it the sound source that is moving? Yes, it's the sound source because the listener is stationary. We need to determine whether the sound source is moving towards or away. The sound source is clearly moving towards because as the speed increases, the apparent frequency increases as well. If it was moving away, the apparent frequency would decrease with an increase in the speed. So with that said, we can then say FL is equals to V plus or minus VL divided by V plus or minus Vs multiplied by Fs. So FL, the apparent frequency, that is 250, that is equals to V, speed of sound in air, which we're interested in, plus or minus VL, our listener is stationary, so that is going to be 0, divided by V plus or minus Vs. The sound source is moving towards, so we must have minus 100 to be specific, multiplied by Fs, which is 180. So that is 180. So that is what we're supposed to solve. First things first, we can divide 250 by 180, and then this gives us v over v minus 100. So I'm going to cross multiply with these big numbers, 250 over 180. I can obviously convert it to decimals, but let me see, 250 divided by 180. Okay, it's just 25 over 18. So I can use 25 over 18 rather. So, and then I'm going to cross multiply without moving to decimal, because if I move with decimal, then I'm just going to be dealing with small numbers. It's still totally fine, but I just prefer this way. So cross multiplying, we get 18v, right? 25v, and then 25 multiplied by 100, that is minus 2500. So 18 minus 25, that is minus 7v, which is equals to minus 2500. So 2500 divided by 7, that is v is equals to 357.14 meters per second. So there we go. That is the speed of sound in air on the day, right? That is 6.4, right? Yes, and then 6.5. Consider the graphs below, A, B, and C. Which of the graphs best represents the wave as the sound source approaches the listener? So which answer did you go with here? A, B, or C? Let me know in the comments. Here we go. This is the grade 12 final examination. Like the grade 12 final examination. The examination that decides the future of most people. So let's take a look at what's happening. So Friday, the 31st of October, is mathematics paper 1. And on the following Monday, the 3rd of November, is mathematics paper 2. Right. That very same week that you write mathematics paper 2, you write physical sciences paper 1 on Friday. And on the upcoming Monday, you write physical sciences paper 2. But let's be honest with each other. There's still a few topics that you're struggling with in math and science. If you go to my YouTube bio, you'll find 3 links: book one-on-one session, course, and email. So where you want to click on is book one-on-one session. You've taken a step in the right direction, and now it's time for you to book a session with me. One-on-one session is focused support tailored to your needs, and the group session is an interactive session for you and your friends. So you can invite your friend, a few friends, and then we can have the session together. So let's say you want to book a one-on-one session. So you're going to click on that. You'll decide on how long you want the session to be. Do you want the session to be an hour, 1 hour, 30 minutes, or 2 hours? Let's say you want the session to be 2 hours, right? So now it's time for you to select a date. Let's say you want to have the session on September the 4th. So you're going to click on that. And after you do that, you're going to see the available times. So if 5 p.m. work for you, you're going to click 5 p.m. And if 6 p.m. works for you, you're going to click 6 p.m. So let's say you want to book a session for 6 p.m. So you're going to click that. After you do that, there's a few information that I need. First things first, I need your name. So let's say, for instance, your name is John, right? The second thing I need is your email. So john@gmail.com, right? And then I need your number as well. Another important detail that I need is the topic that you need help with. So let's say, for instance, you need help with acid and bases, and to be specific, pH calculations. If you have any further question, you can WhatsApp me or give me a call on the number provided, or leave a question and I will give you a call, right? And after you do that, you just need to make a payment to the account provided based on the amount of hours that you want. Final exam is around the corner. You need to act right now.